I am Valentin Fuster for JACC issue of September the 10th of 2019. The FIV original paper is entitled Right Atrial Mechanisms of Atrial Fibrillation in a Rat Model of Right Heart Disease. The first author of this paper is Dr. Roddy Hiram from the Montreal Heart Institute, Department of Medicine at the University of Montreal in Canada. The last and corresponding author is Dr. Stanley Natel, also from the Montreal Heart Institute and from the Department of Pharmacology and Therapeutics at McGill University in Montreal. Let's begin by saying that a number of conditions, including aging, diabetes, obesity, hypertension, and others, may fundamentally have an impact on the left atrium, where most of the cases of atrial fibrillation evolve. However, common conditions principally affecting the right heart, including chronic obstructive lung disease, pulmonary hypertension, and congenital heart disease, may also increase the risk of atrial fibrillation, but the underlying mechanism appears to be in the right atrium. The paper presented today in JACC is based on a rat model of pulmonary hypertension, and it tries to answer three questions which may also explain atrial fibrillation generated by the left atrium. The first is to evaluate the effect of right heart disease on atrial arrhythmias in such animal model of pulmonary hypertension. Second, to determine the mechanisms underlying arrhythmogenesis with the use of optical mapping. And third, to assess the potential biochemical basis with the use of transcriptomic analysis. A beautiful, well-designed study to address the issue of atrial fibrillation generated by right heart disease. Pulmonary hypertension was induced in the male Wistar rats with a single intraperitoneal injection of 60 mg per kilogram of monocrotaline, and rats were studied 21 days later when right heart disease was well developed. Indeed, and for the record, the monocrotaline treated rats developed increased right ventricular pressure and mass along with right atrial enlargement. Interesting observations were made. Observation number 1. Atrial fibrillation or flutter was inducible in 100% of the rats in vivo, versus only in 6% of the control rats. Observation number 2. Pulmonary hypertension rats had significant right atrial cross-sectional area increase, and so fibrosis. Biochemically speaking, it was observed multiple extracellular matrix proteins, including collagen 1 and 3, fibronectin, and matrix metalloproteinases 2 and 9, all being upregulated in such rats with pulmonary hypertension, and all identified in the right atrium. Observation number 3. Optical mapping revealed significant rate-dependent right atrial conduction slowing and rotor activity, including stable rotors in 4 of 11 pulmonary hypertension rats. And finally, observation number 4. Transcriptomic analysis revealed differentially enriched genes related to hypertrophy, inflammation, and fibrosis in the right atrium. This in the pulmonary hypertensive rats as compared with the controls. In conclusion, and according to the authors, right heart disease produces a substrate with atrial fibrillation maintenance due to right atrial reentrant activity with an underlying substrate prominently involving right atrial fibrosis and conduction abnormalities. In other words, we can say that the fibrotic phenomena, as well as the conduction slowing and rotor activity, are both a prominent underlying substrate for atrial fibrillation, originated in the right atrium. Dr. Hans Kottkamp from the Department of Electrophysiology at the Hirslanden Hospital in Zurich, Switzerland, wrote the editorial comment. We can address this interesting editorial in 4 different sections, each section with an underlying sense of how little we know about the mechanisms of atrial fibrillation, but at the same time pointing out that the paper that has been published today in JACC appears to provide some light about the complexity of the atrial arrhythmias, that based in the anatomical presence of fibrosis and the alterations in the electrical activity by optical mapping, both precede the development of atrial flutter fibrillation, and the pulmonary hypertension by itself appears to be a fibrosis maker. The paper today in JACC and other recent information suggests that the fibrotic process precedes atrial fibrillation and is not the consequence. It may be trivial, but probably is not, and we have to turn our thinking around. And going back to the original question, what causes the fibrotic atrial cardiomyopathy, with atrial fibrillation or the maintenance of atrial fibrillation being a consequence but not a cause? In my view, the message today is that atrial fibrillation is indeed complex, and we should be humble enough to accept it, with the paper today in JACC showing some light at the end of the tunnel. Thank you.